Hi guys, today we'll be talking about simplifying the quadratic formula when radicals occur. That is to say, we have our quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And we're going to simplify this, and remember before the break we put numbers in, we said b is equal to, a is equal to, c is equal to, and we simplified. Well, a lot of the times I made it so that we had special cases where the radical here would simplify nicely. That's not always going to happen. And when it didn't happen previously, we just said, hey, make it a decimal. Now, though, we want to practice without making it a decimal. We have been simplifying radicals for a little while, so we're going to use that skill combined with our quadratic formula skill to take care of any problems we might need to. Alright, so let's just review what the quadratic formula does. This formula allows us to say, hey, when we have a graph of a quadratic, which is again our U-shape, we're going to be able to find the roots using this formula. So the roots are just also known as x-intercepts. And they're just where the graph crosses the x-axis. So where the graph crosses the x-axis. So we've got a root here. We've got a root on the left. This thing at the top is again not called a root. That thing at the top is either the top or the bottom, depending on how your parabola is facing. This is again called the vertex. And we did some work with that before the break. But we're especially looking at quadratic formula, simplifying when we have a radical that's not a nice number, so we can't just take the square root of it, and we're not going to make a decimal. Instead, we're going to find these 2 points, or maybe 1 point, or maybe no points, where it crosses the x-axis. Okay, so problems you'll see will be like solve the quadratic formula equation, or solve the quadratic equation using the quadratic formula. So you'll see we have something like 2x squared minus 4x equals 3. The first thing we're going to have to do in order to get our a and our b and a c is get everything all on one side of the equal sign. So my a is positive on the left side, so I'm going to leave everything on the left. I'm just going to subtract 3 on both sides. And because there are no like terms, we're just going to have 2x squared minus 4x minus 3 equals, well, 3 minus.
So we now have our a, our b, and our c. Remember from before the break, we always had ax squared plus bx. Our b is an equal negative 4, and our c is an equal negative 3. So my first step is again to write down the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Alright, so let's substitute the numbers in that we know. X equals negative and then negative 4 plus or minus the square root of b squared is negative 4 squared minus 4 from the problem times a times c. Remember to extend your line all the way across, all divided by 2 times a, which a is 2, so 2 times 2. So we're going to get x equals negative 4, we can simplify to positive 4, plus or minus the square root of, let's see, we've got 16. We have a negative times a negative times a positive, so eventually we'll have a positive. So negative 4 times 2 is negative 8. Negative 8 times negative 3 is positive 24. Right? 8 times, yep, 24. All divided by 2 times 2 is 4. We're going to simplify this stuff on the inside of our radical, so we're going to get 4 plus or minus the square root of 16 plus 24, I believe is 40. I'm just going to double check that to make sure I don't get anything wrong. And yes, it gives us 40. Woohoo! Basic algebra. All divided by 4. And then remember, we can simplify the square root of 40, right? So 40 is 4 and 10. 4 is 2 and 2, and 10 is 2 and 5. So 40 is 4 and 10. 4 is 2 and 2, and 10 is 2 and 5. We're just going to get a pair of them here. So we're going to end up with 2 on the outside, square root of 10. So the square root of 40 is the same as 2 square root of 10. Okay, so x equals 4 plus or minus. We said the square root of 40 is the same thing as 2 square root of 10, all divided by 4. And here at the last point is where we said, oh, just make this a decimal and then multiply it by 2 and then break it apart into your adding and subtracting. We don't need to do that any further. We can leave that just as 2 squared root of 10. This is the simplest form.
So the one thing last to check for after we have simplified, and this is the part where we went from the simplifying part, adding the stuff in last week, from here to here, is we can simplify a little bit. We know when we have a fraction in multiple terms that this fraction is really 4 divided by 4, as well as the plus or minus 2 square root of 10 divided by 4. And what we're going to look for is, does our coefficient, our b, and our term on the bottom, are they divisible by the same number? And in this case, 4, 4, and 2 are divisible by the same number. So we're going to reduce our entire quadratic formula by dividing both the top and the bottom by 2, because that's the largest number that all three of these are reducible by. So we can say that this whole term is equal to, divide 4 by 2, we get 2, plus or minus, divide 2 by 2, we get 1, which is really just a square root of 10, all divided by, because 2 divided by 2 gives us 1, 1 square root of 10 is the same thing as just a square root of 10. 4 divided by 2 is 2. So we're ending up with 2 answers, and we could get the decimal form if we want to, but we're going to try to avoid decimals. They're not precise. So we get x equals 2 plus the square root of 10, all divided by 2, and x also equals 2 minus the square root of 10, all divided by 2. So you could leave your answer in like a variety of fashions. You could leave it right here where you have the plus or minus, if you like that. You can also leave it as this or as this, but we do not want to have equal sign equal darker. We do not want decimals. Again, decimals are imprecise. These numbers have irrational answers because they do not ever end. The square root of 10 is not a nice number. It keeps on going forever in a random pattern that we can't identify. So what we're going to do instead is just leave it as this. This is an exact answer. This is precise, and that's what we're looking for. Okay, so let's do one more of these problems and we'll get some practice on it. Alright, so second example. Example 2, 0 equals 3x squared minus 2x minus 7. And again, I didn't write the directions out, but it's the same directions. Solve this quadratic equation using the quadratic formula. So we have to identify a, b, and c. So we have our a, our b, and our c. They're in the correct location. It always goes a, b, c in that order, from x squared to x's to no x's. Highest degree term down to the lowest degree term. Standard form like we talked about earlier. Okay, so x equals negative b plus or minus square root of b squared minus 4ac, all divided by 2 times a. So negative b is negative 2 plus or minus the square root. B squared is negative 2 squared. Don't forget to put that in parentheses. If you type this in your calculator, you won't make a mistake. Minus 4 times a times c, all divided by 2 times a. Oops, ink smudging a little bit. Need to watch myself. Okay, so x equals negative 2. We can simplify to 2 plus or minus. Let's see. Negative 2 squared is going to be positive 4. So square root sign, we'll start it. We'll wait till I end it. 4 times 3 is 12. Times 7, so 12 times 7 is going to give us 84. Negative times a positive is a negative, times a negative is a positive, so 4 plus 84, all divided by 2 times 3, which is 6. Okay, so we get 2 plus or minus the square root of 88, all divided by 6. And we can simplify the square root of 88, so we know that 88 is 8 times 11. 8 is 2 times 4, and 4 is 2 times 2. So we get all the way down my ends. I've got a 2, so the square root of 88 is 88, not just 8, is 2 times 2 times 2 times 11. We've got a pair here. Remember, the square root is asking what number multiplies by itself. Since we have a 2 that multiplies by itself, we're going to take the 2 to the outside. And we're left with 2 times 11, which is 22 on the inside. So the square root of 88 is equal to 2 square root of 22. So we can say x equals 2 plus or minus 2 square root of 22. There's a lot of 2's on this. All over 6. And again, we look at our two different fractions. We've got 2 over 6, and we also have 2 square root of 22 all divided by 6. We're looking at our whole numbers on the outsides, and we're looking to see if 2, 2, and 6 can be divided by the same number. We know that we can divide each of these by 2. So we're going to divide each of these by 2. So 2 divided by 2 gives us 1, plus or minus 1 square root of 22 is the same thing as just the square root of 22. And again, we don't divide the number on the inside. We're only looking at our numbers on the outside. And then 6 divided by 2 gives us 3. So we can say x equals 1 plus or minus the square root of 22 all over 6. And that is where this graph, were we to actually graph it, would cross the x-axis. Okay guys, I know it's been a long video. Make sure you have all the notes and come get your practice sheet from me. Alright, thanks, bye.